started. So hello everybody. I've got a nice intimate session today, so you're going to get nice one-to-one talks here. So my name's Jamie Coleman. I'm a developer advocate for IBM for the next 2 weeks, and then I'm leaving IBM. I'm actually joining Sonatype, one of your sponsors, weirdly enough. So if you see a mention of Sonatype in this presentation, that is why I'm being nice to my new bosses. So yeah, I'm a developer advocate at IBM. I've been at IBM for about 9 years now. I worked on container technologies at the beginning, worked on some DevOps stuff, and now here I am as a developer advocate. So basically anything Java, anything kind of cloud native, things like that. So let's get started. Has anyone heard of Poquito here? No, okay, good. So you should hopefully learn something today. Poquito is an epic bit of technology. So what I'm going to talk about today is, first of all, polyglot programming applications, what they are, and why you want to use them. I'm going to talk about different programming languages that we use, what a build pack is, and how it can help you with things like compliance, security, control, and maintainability. Then I'm going to introduce Paketo to you, and as none of you have heard of it before, that hopefully you should learn something, and I do want you to try it. Then I'm going to talk a little bit about the technologies that I'm going to be using with Paketo, things like Open Liberty, MicroProfile, etc. And then hopefully I'll give you a little bit of a demo. We'll see, because I have very, very limited internet access in this room. Right, let's get started. So what are polyglot applications, right? Have you three heard of polyglot applications before? Yep, one person. Okay, cool. So what are polyglot applications? Well, basically, it's an application that's written in lots of different languages. So the reason we do that is to capture the functionality or the efficiency of these different languages. So for example, in the product I work on, we are very prominently Java. But that we do write stuff in Python, etc., where it makes sense. Java isn't the perfect language for every scenario. So using polyglot applications can help you in lots of different ways. It allows development teams to choose the technology stack they want to work on, rather than an organization saying you have to use Java, you have to use Python, things like that. And if you abide by the 15-factor rules, now who's heard of the 12 factors here? 12 factors? Yep, okay, well there's 3 more now, so I'm going to talk a little bit about what those extra ones are. But if you abide by those, then it can make creating applications with different languages nice and simple. So these are the new 15 factors. Now, 2 of you put your hands up and you know what the 12 factors are. Can you tell me what the additional factors are in this list? There's 3 additional factors from the 12. Can anyone notice what they are? Telemetry is one, yep. Right, I'll help you with the next slide. So API first, telemetry, you got 1, and then authentication and authorization. Now, ridiculously, security was not included in the first 12 factors. Like how on earth they managed to miss out, because authentication and authorization is essentially security. How they didn't think about that when they created the first 12 factors, I have no idea. API first is essentially designing and defining your APIs and your endpoints before you actually write the code that does anything. Telemetry is just the ability to look at what's going on with your applications when they're in production, etc. And again, this is mainly about security. And again, I am so confused as to why security was not included in the first original 12 factors. So something to think about here. It's all well and good as trying to save our organizations money, but we need to think about it in a different way, because money it's not saving us money as developers, it's saving our organizations. So I like to think of this as making our applications efficient to save energy. So some random facts here. There's over 500,000 data centers around the world. The area of land they consume is around 6,000 football pitches. And if you took all the energy, and this was in 2019, if you took all the energy they consume, that's about 1.5 times the United Kingdom's energy consumption per year. And that was in 2019. So it's probably more 2 times now. And if you think about that, these data centers, pretty much the whole population of the world use them. If you've got Facebook, Twitter, whatever, in the back end, all your data is going into data centers that we don't see, and they're consuming huge amounts of resources. So luckily, the hardware engineers of the world have done their part. If it wasn't for the hardware engineers, this curve here, we would be up here now. Now, hardware engineers have changed hardware a lot. They've tried to make it as efficient as possible, so they've managed to stop that trend. But as engineers, we're the ones responsible for saving the world's energy. We're the ones that, if anyone's going to help the world, it's going to be us. So it's our responsibility, essentially, to make sure we create efficient applications. The problem is with Java in the microservice world is you have a big overhead. So JVMs originally were kind of designed to run lots of applications, not one application, 2, 5, 10 applications, which is great, but we're not doing that now. We're putting one application with one runtime and one JVM. So you've got a massive, massive overhead when you're creating lots of microservices. So sometimes Java just might not be the right answer. And the problem is, so JVM vendors have tried a lot. They've tried to optimize their JVMs to make them as efficient as possible with things like startup times, ramp-up time, memory footprint, response time, and CPU and throughput. But when you make changes, say, if we lower the amount of time it takes to start up, that might have problems with throughput, or it could have problems with ramp-up time and things like that. So we have to be very, very careful. Now, there are lots of different JVMs out there. OpenJ9 is the one I'm very briefly going to talk about. This was IBM's JVM. We open sourced this about 5 years ago, a week ago actually. And so it's a really great JVM because it can handle very constrained environments and very big ones very efficiently. So on the cloud, we're all renting resources. Say we rent a unit of resources, but if we go over that, our applications can crash. If we have a memory leak, our applications can crash, whereas OpenJ9 has some technology in it that if you run out of memory, it still keeps the throughput high. So this is just some stats from the OpenJ9 website. This is comparing it to hotspots at Oracle's JVM, and as you can see, it's starting up in half the time, it's using half the footprint, and the CPU is handling really well when it's under load, and that is quite important. So, good thing about Java, even though it's over 25 years old, I found this research on LinkedIn, which is amazing, which rates the different programming languages and their energy efficiency. Java is still the 5th most energy efficient language out there, which is very impressive because of how old it is. So it's still a great choice for your applications, even when you're trying to look at the energy efficiency. And always relate energy efficiency to performance and things like that. So the good thing about Polyglot applications is you can increase engineer creativity, because if each team has the option to create their own stack, that makes them more interested in what they're doing. It can speed up the time to market because you're using languages that are more suited for what you're trying to create. You can draw from a bigger pool of talent, so you don't just have to say hire Java engineers, you can hire engineers that are experts in lots of different languages, and you hopefully end up at the end of it with more efficient applications. So things like LinkedIn, they've used Polyglot applications from the beginning. So there is a lot of corporations out there using Polyglot applications because sometimes it just doesn't make sense to use a single language for everything. But there are disadvantages. One is complexity. Obviously, if you're trying to manage 5 different languages in one application, it can get a bit more complex, and you can have scaling issues. But generally, the advantages outweigh the disadvantages quite a lot because you can create really efficient applications. Right, so what are build packs? Have you heard of build packs before, anybody? No? All right, a build pack is essentially something that transforms your application source code into container images. And these container images can be used by anything. This was first conceived by Heroku, and they're the people that created the 12 factors that missed out security. And they also are the ones that created the extra additional 3 factors after they realized they needed some. So this was created by Pivotal and Heroku in 2018. It's fully open source, which is amazing. So what are the advantages of build packs? Well, first of all, you have advanced caching. So this is basically robust caching is used to improve the performance of your application. You've got auto detection. Auto detection, essentially, images can be built directly from source without any additional instructions. So you don't need Docker files or anything like that. You just point this at your source code and it will do everything for you. It also provides a bill of materials, which is very useful, and I'll talk a little bit about that in a moment. This is something that is going to be very, very important in the next 2 years, and I'll explain why in a moment. It's also modular and pluggable, so you can use multiple build packs at once. So when I run the demo, we'll be using 2 different build packs to create our application. And it's got multiple language support, so it supports all the main languages, which is really good. It's also multi-process, so images can have loads of different entry points. It's got a minimal app image, so when I create the app later, it'll be something like 70 megabytes, as opposed to if I didn't use this technology, it'd be more like 300 megabytes. It allows you to rebase images without rebuilding. Allows you to reproduce the same builds over and over again without sharing configuration and things like that. And reusability allows you to leverage pre-built build packs. So these build packs are created by loads of different companies all over the world and allow you to essentially get started very, very quickly from your source code. So the first thing is compliance. So compliance, what is that? Well, basically ensuring your software and licenses are used correctly. The top causes of software non-compliance are complexity, inadvertent misuse, so not knowing you're using the wrong licenses, lack of software asset management procedures and tools. So if you don't have those in your corporation where you could just use a license and not know you're breaking the law or breaking any terms of your contract, lack of education, internal misuse. And something that build packs can help with is inadvertent misuse and lack of software asset management, because they basically provide you something called SBOMs, and I'll get onto that in a moment. So stacks and build packs, essentially ensure your stacks are updated and secure. So build packs use the notion of something called a stack, and when you have an image, you have two. You have your build image and your run image. And these are kept separately to try and make your environment even more secure. And it has a lot of security and hardening features. So if you're using Ubuntu, for example, to get the latest, normally if you're using a container, you'd have to rebuild your container to get all the latest updates, etc., from the base image. You don't have to do that with build packs. Build packs automatically update the operating system level, so you don't have to care about any vulnerabilities in your operating system. They will automatically be patched for you, and that's usually within 2 hours of Ubuntu providing those updates. They will go straight into the bottom layer of your image, so it makes maintaining them a lot easier. The stack images are run as non-root users to avoid some security problems there. Each stack has detailed metadata describing the image's components. Each stack has separate images, like I mentioned, for building and running, and the build and run images have different IDs, and this essentially helps with security. So it means that sensitive files and dependencies installed at build time cannot be corrupted at runtime using malicious code. So this is where we go to control, and this is where it really helps a lot, and hence why I'm shouting out to the new company I'm going to be working for. So with control build packs, you have full control over the operating systems, the languages, and the package management your teams use. This allows you to connect to a private Maven repository to use dependency management software. So most of us will just pull down stuff from Maven Central. So Sonatype is the company actually behind Maven Central. They've been running it for years. But most people are just pulled down from Maven Central. Now, that's not always a good thing because, as we know with Log4j and things like that, you can pull down bugs, you can pull down lots of different nasty stuff that you don't want to do. So basically what build packs do is they provide you with something called SBOMs. Have you guys heard of SBOMs before? Okay, so you really should know what this is because the US government just made it law that every provider has to provide SBOMs, and if you don't, you cannot sell to the US government. And I guarantee you the EU and most other countries around the world will be implementing this law very, very soon. So an SBOM, if you don't know, is a software bill of materials. So basically what it does, it goes through your code, it finds all your dependencies, it will then look at those dependencies to see if there's any vulnerabilities in there. But a lot of the times when you have these software that go through your code, okay, I can look at the dependency, but if you've ever been through Maven, you'll notice that dependency uses 4 more dependencies. You'll go to one of those dependencies and they'll use another 10 dependencies. So it's really, really key that you use these SBOMs. So again, SBOM is a software bill of materials. It's a list of all the packages and libraries included in your application. It's essentially the digital equivalent of a manufacturing bill of materials. So it includes all the sub-assemblies, it includes, again, all the dependencies, it even includes all your licenses to make sure you're using the right licenses, etc., and things like that. So SBOMs, essentially, for organizations building a project, maintaining a bill of materials is a useful way to track your project's dependencies, and keeping track of the package versions basically makes sure you don't have dependencies that have vulnerable components in them. So the minimum kind of requirements for an SBOM is to have data fields, automatic support, and practices and processes. And like I said, I think it was last week or the week before, the US government made it law that you have to provide this with any applications you sell to them. So I hadn't heard about SBOMs until probably about a month ago, but this is really something that is critical. If you sell or you have any customers that are governments or anything like that, you will have to do this before you be able to sell your applications to them. There's this really cool thing called Bomb Doctor. Let me see if I can open it. Yeah, so basically this is a Spring application, and what it does, you can point it to any GitHub repo, and this is a beta, just be warned. And what it'll do, it'll look at all the dependencies, and then it'll look at what dependencies those have, and then find all the dependencies all the way down the chain. And what it does, it rates each dependency depending on if it's got any vulnerabilities in it, are you using the right version, and things like that. So try tools like this And yeah, have a look at your source code, see what's in there. So you can go and click on this little character over here. He'll tell you basically what's going on with my application. So basically he's saying, I've made it to the launch pad, but there's definitely some stuff I can do with my dependencies to make it better. So do check out these kind of technologies, because you'll be surprised about how many vulnerabilities and how many versions of things you're using that you really, really shouldn't. So yeah, do check out these different technologies like that. Right, moving on from SBOMs, now you all know what they are. Maintainability. So maintainability is something really important, and it's something that gets more and more difficult when we have bigger applications with more microservices. So having good maintainability helps your organization save money and energy in the long run. So what build packs offer are things like auto detection of source code. Like I said, I can just go to my Python code and the build pack will know it's Python. It'll know the runtime I'm using. It'll also know the best JVM to use for what I'm trying to do, and it'll do all that for me. I don't have to configure any of that. I just point at my code and it does that. Using multiple build packs to create application images. So like I said, we're going to be using two. We're going to be using the Open Liberty one and the OpenJ9 build pack, and they kind of combine together to build your application image. The image only contains what's required, so it's very good at stripping out all the stuff it doesn't need. Again, you get instant updates to the base image, so I don't have to update or rebuild my applications. All the updates go straight into the base layer. And you can reuse build packs, and they're built by the whole community. So for example, with Open Liberty, we have a whole team of people that make sure our build pack is completely up to date. And it's the same with pretty much all the other vendors that use them. And you'll probably be surprised that they cover most of the technologies you're using. So if you're comparing it to some of the other different technologies that may be similar, as you can see, build packs have a lot of functionality and features. And again, this is all free and open source, so do check it out. So I'm going to introduce Poquito. So what is Poquito? So Poquito is basically what takes the build pack, takes your source application code, and builds something. So Poquito, like I said, it transforms your code into a ICO container image, which you can pretty much use anywhere. It's open source and provides production-ready build packs for PHP, Java, Node.js, Go, Net Core, things like that. And it allows you to easily build applications and keep them updated. So you don't have to bother with Docker files or anything like that. Poquito will do all that for you. So how does it work? Well, essentially, like I'll show you in a minute, you basically just you install the pack CLI, you go to your source code, you just basically use the pack CLI, it'll package it all up for you and it'll do everything for you. And it supports Gradle, it supports Maven, it supports Linux, so it supports lots of different things. Now, of course, you get to the point where you might want to configure or change what Poquito does. That's fine. You can pick your own JVM versions, and most of the different JVM versions are available with Poquito. So it's entirely up to you how you use it, but it's very, very easy to configure. So yeah, so Poquito can use alternative Java application servers from the default. Now, how this works is it will look at your source code structure. So, for example, if I've got my source code structured in a way where I'm providing a Open Liberty configuration file, it knows I'm using Open Liberty. So it'll go and get that runtime for me. I don't have to specify anything like that. It'll just go pick it up. The only thing I'm going to specify in the demo is that I'm going to use the OpenJ9 server. But if I didn't, it'd probably just go down Oracle's hotspot or OpenJDK or something like that. But it's up to you if you want to configure it. And when you launch this stuff, all you have to do is add in the addition of like environment variables if there's anything inside your container you want to configure. So I'm just going to quickly introduce Open Liberty. You guys heard of Open Liberty before? Anyone? No? Okay, so Open Liberty is a runtime offered by IBM. This was essentially, so I work in the WebSphere organization. We've all heard of WebSphere. And WebSphere it's getting a bit old now. It's a very robust application server. I mean, one of our customers has been using it for 15 years and has never shut one of his servers down. When they asked us to come and try and figure out how we can turn that into microservices, we all just kind of went, you might have to rewrite this. But yeah, so Open Liberty, we kind of went back to the drawing board and we wanted to create something that was a lot more cloud native and a lot more developer friendly. So Open Liberty's just had its 5th birthday today, last week. So it's been around for about 5 years now. And really the main project goals of Open Liberty were to focus on code. We wanted to make life easier for developers. So you can make changes to your code, your test code or your configuration, and you don't have to restart the runtime. It's got true to production testing, so it uses things like test containers and they're fully supported. This was one of the first IBM products that was ever containerized, and that was my first job at IBM. I'd finished university, and they said, "Oh, okay, do you know about this thing called Docker?" No idea what Docker was. They said, "Okay, well, can you put our application runtime in a container and build a pipeline behind it to do automatic releases?" Okay, sure. So we've been in containers for a very long time, and it's very efficient in containers. And again, we want to create tools and make it flexible, so you can use all the different developer tools you normally use, and it supports nearly all of them. So again, going back to the developer experience mode, this dev mode enables you to make code changes, configuration changes, test changes, and not have to rebuild your application every time. And so it allows you to focus on code, and it'll put those changes into your application, into the runtime within milliseconds. So it's nice and efficient. And again, focusing on developer productivity, we wanted developers to use the tools they're familiar with. I presume most people are using Spring Boot. So for example, if you switch out Tomcat with Open Liberty with Spring Boot, you get double the throughput, which means technically, in theory, you could run half the microservices you do with the same, basically the same application running half the microservices. So do play around with it, and if you are using Spring, do check it out. It's very, very efficient. The startup time might be maybe a second slower, but if you don't care so much about your startup time, and you really care about the throughput, Open Liberty is a really, really great choice for your Spring applications. Okay, so Poquito and the Liberty build pack. So Open Liberty has supported Poquito pretty much from the get-go. So Poquito's been around quite a few years now, like 2 or 3 years. So the Poquito build pack for Liberty is a cloud-native build pack, and essentially it contributes Open Liberty or Webs for Liberty for Java EE and Jakarta EE and MicroProfile support. And you can, like I mentioned, use Spring as well. So if you want to learn more about that, you can go to our GitHub and just type in Poquito, and it will tell you all the different information about how we support it, etc. There's lots of different profiles and different versions of Open Liberty you can use. The 4 was obviously a bigger one, but there are smaller versions that are down to like 10, 50 megabytes in size as well. So getting started with Poquito, the first thing I advise is to essentially look at your own applications using things such as SBOMs, because like I mentioned, they are going to be very, very important in the next few years. I don't know when the EU is planning to implement these laws, but they will do it, I reckon, in the next year or so. So if you have government clients, customers, you will not be able to sell software to them anymore unless you provide this. So SBOMs are very, very important going forward. And they're very good for yourselves as well, because you can see what dependencies you're using, you can see what licenses you've got, you can see the vulnerabilities in those dependencies, and then it can tell you can use the SBOMs to advise you what versions of these dependencies you should be using. Because like I mentioned, you download a dependency from Maven, and that depends on 5 other things, and those dependencies depend on 5 other things. So yes, the top dependency might be okay, but if you go down the tree, you might find that those dependencies are out of date or vulnerable. So MicroProfile and Jakarta EE. Anyone here heard of MicroProfile and Jakarta EE? Yeah, okay. So MicroProfile essentially is an enterprise Java, basically open source Java specification that is really built for building enterprise Java microservices. And at the time, there wasn't really an open source specification for building microservices. So essentially a big community of vendors, individuals, and organizations all came together to create MicroProfile. And if you haven't tried MicroProfile out, do try it out. It's very, very fast and very efficient. But the main thing about MicroProfile is it's vendor neutral. What does that mean? Okay, well, vendor neutral is basically if I have a problem with a current vendor or an implementation, I can then move my applications quite easily to a different vendor. Whereas if it's not vendor neutral, you're stuck with them. And if they make changes which your organization doesn't like, etc., you have to either go along with those changes or you have to rewrite all your application, which is not good. Whereas MicroProfile, you can port it to lots of different runtimes and not have a problem. So this is the current MicroProfile stack. Some of the specifications are shared with Jakarta EE. That was because they were needed for MicroProfile anyway, and we didn't want to develop them in parallel with Jakarta EE. It didn't make sense. So essentially, some of the specifications are shared with them. Now, you can use this for reactive programming as well, using things like reactive stream operators and reactive messaging. So Jakarta EE, what is that? Well, essentially, this is where Java EE has gone. It was open sourced and given to the open source community, don't know, quite a while ago now, 4 or 5 years. And basically, it's a set of specifications for building enterprise applications, things like such as web services, etc. So Jakarta EE has some of these are some of the founding members of Jakarta EE, so thank you everybody here for contributing to that. And another cool thing about Jakarta EE is it's got this zero migration policy as well, which means you can move your application code up to the latest version of the Open Liberty Runtime or the latest version of Jakarta EE, and none of your code should break. Because that's always a pain when you want to go to the latest version of something. You have to test for like a year, maybe longer, depending on what you're doing. But with these technologies, you don't have to do that. You should be able to take the latest versions of stuff, and it should work. And that's important because these technologies and these companies that are producing these technologies, they want you to use the latest version. Like in Open Liberty, we have 500 developers creating Open Liberty. But if people are on 3-year-old versions, then, well, they're not getting the benefit of what these 500 developers are creating. So having the zero migration policy is really important. And I'm not sure if, I've never known another runtime or anyone have this policy. So it is very, very important if you want to kind of, stay current and use the latest technologies without having to do like a year's worth of testing, etc. All right, so I'm going to try and run the Poquito demo. My internet was being a bit weird today. So basically, it's a very simple application I'm going to show you. So basically, all it is 2 classes. This one is just the REST endpoint, and this is just a REST endpoint. And all it does is return the system properties of the application, of the system you're running on. So very, very simple application to show you what we're going to do. I'm going to quickly build that application. So I'm in the folder where this is. There's no configuration elements here or anything like that. So if I go back here, there's the POM for Maven, and having the POM then, Poquito knows that we're going to use Maven to build this, but other than that, there's no specific configuration here for Poquito. All I'm doing is pointing Poquito at that directory. So I'm going to build this. Again, all I'm really specifying here is some environment variables and the fact that I want to use the OpenJ9 build pack. Other than that, I'm not specifying that I want Open Liberty build pack or anything like that. It just knows. And the way it knows that is by my directory structure, because in here, I have a Liberty directory with the server XML. This is just basically configuration, just including the features you need. But because it has that, Poquito then knows that I want to use the Open Liberty runtime, and it'll build that for me. Okay, it looks like the demo gods are happy with me today because it looks like it's building. So what it'll do is it'll go down and pull the individual images. I have some of those images ready, so you don't have to wait 10 minutes for them to pull down on the slow internet connection. And essentially what it'll do is what will output is an image for me. And this image is a production-ready image. It's supported by all the main vendors, so it doesn't matter, all the different database services and everything, they're all supported by Poquito. So what it's done, it's gone and built that for me. And again, I have done no configuration here. All I've done is pointed it at my source code. So now I should be able to run my application. That should start up hopefully quickly. If I use Docker, bear in mind I'm writing with one hand here, so bear with me. We should see our application started up. And if I go here and refresh this, give it a second to start up, we should see the system properties of the container this is running in. And really what I wanted to show you is how easy it is to do this. There we go, there's the system properties. That's all this application is doing. And within, 3 seconds, with no configuration whatsoever, I've taken a Java application, I've built it, I've got the runtime, I've got the JVM, and it's built it into a container image. I've just deployed it locally with Docker, and this is it. So, and it's really good for Polyglot programming because I can point this at any language and it knows what it needs for each language. So Poquito is very, very good if you're using Polyglot programming, but it's also good for lots of other reasons, like I mentioned in the presentation. So I was going to quickly show you a little bit of kind of how an SBOM looks. So this is something Poquito produces. So when you create your application, it will produce an SBOM. This will then produce basically a list of all the things you need to look at, things you can be updating and things like that. So it's really useful when you want to know what's going on and what's packaged up in your application. So that's all good. I'm just going to stop this so it doesn't consume the Wi-Fi while I'm here. And I'm going to, you're quite lucky because it's lunch next, and I've finished this relatively quickly. So I'm just going to do a quick recap here of some of the stuff we've learned today. So Polyglot applications, they're great. They can provide loads of different benefits. They can take advantage of what each programming language has to offer. Build packs are really cool as well because they make basically this whole process a lot less complex. and provide loads of different functionality like I mentioned, advanced caching, auto detection like you saw. Again, I provided Poquito nothing and it built everything for me. Don't have to worry about Docker files anymore, which are always a pain. And again, it supports pretty much all the main languages. It'll create an image which is tiny. I'm pretty sure the image I built was about 70 megabytes. And yeah, reproducibility and reusability. And Open Liberty is completely supported with this, as well as lots of other runtimes. I'm pretty sure Quarkus and all the others are all supported as well. So yeah, do check out this technology. It's completely open source and completely free to use. Here's some of the links for some of the research I did in here. I'll provide the presentation afterwards so you can actually click on these links because they don't really make much sense at the moment. And here's some links to some of the materials I talked about today. So if you want to know more about MicroProfile, Open Liberty, and things like that, do check out some of those. Just to kind of finish off, you are free to connect with us. We have a very active social media. We always respond to anything, questions about the technology, questions about related technologies. We are a fully open source product. We kind of try to distance ourselves a little bit from IBM. So if you go to the Open Liberty website, it will look nothing like what you're used to with Open Liberty. That's because we really wanted to be an open source project at our core, and we didn't want it resembling all the other clunky stuff we have online. If you want to know more information about any of these technologies, I will be around the conference until tomorrow. I will be at the unconference tomorrow if you want to ask any questions about that, or just add me on Twitter. But what I want you to take away, there's two main things here. And there's no excuse because MicroProfile, Jakarta EE, Open Liberty, Poquito, all completely open source and all free. And I'd try Poquito, even if it's just to get an SBOM and have a look at what you're building, have a look at the dependencies you got. You will be shocked about how many of them are vulnerable and how many of them are out of date. And I guarantee you, your organizations will be very, very thankful when you turn around to them and say, look, all this is out of date, but we can update this really quickly. I guarantee you they'll be very happy that there isn't 10, 20, 100 vulnerabilities in your application codes. So do check out Poquito. Do check out SBOMs. Again, they are in the next so it's a law in the US. Companies have got 2 years to be compliant. And I'm pretty sure the EU and most other governments around the world will be doing this as well. So do think about it because it sounded like no one had heard of them. I had never heard of them until about a month ago, and then I've been a bit shocked at the fact this is going to be law. So do check them out, if not just for your organization, just to make sure your applications aren't vulnerable and in future you use the right dependencies. So with that, I'm going to all let you go and have a nice early lunch. Thank you for listening to me. I know there's only a few of you here, but yeah, it was great to see you all, and enjoy the rest of the conference. Thanks, everybody.